Masuri here. So let's get back to where we left off. Actually, if you remember, last time we talked about the OpenGL and about how far we can get close to the GPU and command to draw stuff in shapes. And we experimented with the lightweight Java OpenGL library, which stands LWJGL. And we created a window. We used the sample code. And we tried to draw a bunch of shapes. Actually, we draw, if you remember, we draw circles, we draw rectangles, polygons, and lines, and all that stuff. And so if I want to actually summarize what we've talked about the OpenGL, what we are trying to accomplish here is that we want to describe our UI content, the graphical user interface content, and we want to draw it, paint it on some kind of a canvas. And this is what pretty much actually all of the graphical user interface frameworks do out there, like for example Android or Flutter or you name it. So I've myself digged into the code of the source code of the Android, and when you go too deep, you just see layers of libraries on top of a canvas. So everything that you see, all those fancy UIs in your iPhone or your Android, all of them are being created frame by frame. All of them have got this while loop, all of them. No matter it's a game or it's an application that you are running, all of them has got some kind of a while true forever loop. And inside this loop, they actually try to collect the how can I say, the description of the content and the painting that you're going to draw. And you just try to explain and describe your content by buttons and text fields and text and images and shapes and all that stuff. And then the Android, which Android, the only thing that is Android doing, not the only thing, but the main thing that the Android is trying to do is that it grabs those high-level explanation of your UI, and then it tries to convert it to a bunch of draw calls on the OpenGL. So for example, when you have a button, which is a rectangle, and you ask the Android to draw that button for you, all it does is just it commands a simple draw polygon. Actually, it commands to the GPU through the OpenGL, and it tries to build in that while loop. It tries to build that frame. After it builds the frame, when the frame is ready to be shown, it swaps the next frame and it draws to the actually surface of your device. And that is what we are trying to do here. And we don't want to write a fully fledged graphical user interface framework, but we want to get a sense of how these stuff are working actually deep down. So we will continue until we get to some extent, actually, for example, get our own button and a text field, maybe, or not a text field, a label, text label on top of this screen, which and then at that point, actually, we will see how all these frameworks are working internally, and then we will move to a real framework, and it might be Flutter, but we will talk about that later. Okay, so we have this draw content here, and I've run the program here. We have drawn a rectangle, a circle. We have created our own higher level library functions on top of the OpenGL, because there is nothing about circle or rectangle, the OpenGL, your graphical processing unit, your GPU does not know anything about the circle or about text or about images. You know, what is a, for example, take this IntelliJ idea. This is a very fancy UI. You see this tree here. You saw these texts in these, again, these are texts. We can click on them. You see these drawings. These are vector shapes. And we might have some images and it will draw for us. So basically a graphical user interface, no matter the type. I just said, you know, it can be a game, fully fledged game with that, all that actually fancy graphics, or application or desktop application or mobile application. All of these GUIs are being built actually just through painting simplest stuff, you know. So this fancy UI will be actually translated to maybe thousands of draw polygons to the OpenGL, and we are seeing these live UI, but this is not live. This is a picture frame by frame, which is being drawn for us, and our mind get the delusion that this is live, and we are seeing this live, and this blinks here. We are selecting, we are doing all this stuff, but all this is doing is that all it does is that it has got its own while true loop inside it, and it is translating all the current state. Actually, it tries to draw a painting which represents the current state at each frame. So so all we need for actually having a fancy UI, the most fanciest UI that you have in your mind, all we need literally is a bunch of draw functions on top of a canvas. So we need a canvas, then we need to be able to draw simple shapes like circles, rectangles, also more complicated shapes like defining a custom path and then asking it to actually fill it or connect it as a polygon, as a shape. And also we want to be able to draw, I think I mentioned the text is, which is very important and it's very hard, which we'll talk today. And also we want to be able to draw vector images and all that stuff. If we have these functions on top of the canvas, then we have everything we need. Of course, some other stuff that we will get into, like handling events, touch events and keyboard events, which is more about windowing stuff, not about canvas itself. But first we want to focus on the canvas and the draw functions. So we have these draw functions on top of the OpenGL, and let's actually see how we could draw a simple text on the screen. So in order to draw a text, you might think that, okay, we ask the OpenGL, maybe there is a function inside the OpenGL that we can load our TTF typeface font file. We can load it, we can give it to the OpenGL, and we can politely ask it to, for example, draw, for example, I don't know, some mascot, for example, my name on this screen, or hello world. And it will actually magically try to actually, you know, get the stuff from off of the typeface file and then draw the content, draw the text on this canvas, on this red canvas that we have. But as we said before, even the simplest shapes like rectangle is not defined in the OpenGL. All the OpenGL does is that all we can do to the OpenGL is that we can tell it to draw points and lines, and also connect lines together and form a polygon. This is I think, yeah, as far as I know, this is pretty much all the thing that we can do with uh, OpenGL. This is all the thing that your graphically processing unit is doing. So the question is now, this begs the question, for example, how, now we will get back to the text, but for example, the question is how we can draw an image on the canvas, on the screen. And the answer is that we can define our shapes through points, lines, and polygons. And also, we can tell the OpenGL to how paint the colors of the pixels. So when we define our shapes, when we say, for example, I want a polygon with these points surrounding it, it will draw that polygon for us. Drawing means that it will try to actually, how can I put it now? It will try to understand and specify the pixels. So what is a canvas? A canvas is just a live image, a picture, a live picture that we can draw. So what is a picture? A picture is a bunch of pixels. And all that we need to do is that we need to tell this painting to clear at each frame, clear, and then, for example, turn on and off pixels and tell the colors of each individual pixel on this screen. So this canvas we've got here is a 300 by 300 pixels picture that we are actually seeing here. But when we tell the OpenGL, okay, go ahead and draw a polygon for me, or you draw a line, all it does is that it tries to calculate all the pixels that will be turned on. By turning on, I mean that will be colored in the next frame. So we've got a frame, we've got a canvas, it has got pixels, rows of pixels, and so if all the picture that you see everywhere is a bunch of pixels, and all we need to do is to define how and which of these pixels are actually going to be colored at the next frame. So we tell the OpenGL, the OpenGL tries to build that canvas, build that picture, and calculate the pixels off of the shapes that we explain. So now that we understand, we know that there is nothing such as circle or rectangle. Also, for drawing an image, all we need to do is to we load our, for example, JPEG file off of the disk, and then we try to encode it and get the pixels, because what is a JPEG on your disk? It's a bunch of colors defined, the pixels and the colors of that image. So we ask the file about each individual X and Y pixels. We get those pixels and we paint. We get the color. Of course, what is a pixel? What is the information of the pixel is alpha, red, green, blue, 4 bytes or 3 bytes for each pixel. We get those colors and we then tell OpenGL to color that specific pixel with that color, with that color. And all of a sudden, so for example, we see this picture that we've loaded from the file, and that is how images are being drawn. Also, when there is nothing about circles and rectangles, of course there is no drawing text on OpenGL library, because OpenGL, and I don't want to repeat and repeat. So how we draw a text in OpenGL, we have to define the glyphs or characters of that text, and we have to calculate and draw polygons and draw paths and tell the OpenGL to color those paths. So it is very hard to draw text because, for example, each typeface has been designed by some guy. And so what is a typeface? Well, the question is, what is a typeface? A typeface is the definition of a bunch of glyphs. They call, for example, character A, B, the shape of the A, B, C, D, 1, 2, 3, all those characters. They call them glyphs in the typeface. So a typeface file is simply just a bunch of description of glyphs. So how they try to define the glyphs, the boundaries. And the answer is that, for example, especially in the TTF file, .ttf files, all the designer is doing is that the designer opens the Illustrator and then draws a bunch of Bezier paths. If you have experience, so if I want to put it simply, the designer just grabs the pen tool of the Illustrator, Adobe Illustrator, and then it, for example, defines the glyph and the shape of the A character, for example, capital case A character. For example, it has a drawing on the paper, and it tries to replicate that drawing through defining a polygon, the points of a path, and it forms a polygon. And then, so the designer defines a polygon, which is made of the points on a path, closed path, and then it saves all those paths to a file named TTF. So in order to draw that same exact shape of the, for example, A character, which is inside the TTF file, we have to somehow read that path, and we have to define, actually order and command here those paths. So so far you know that all we can do here is we can draw polygons. That's what we can do here. Okay, so that when we have the coordinates of a path, if we grab those coordinates and we try to scale it based on the font size, then we convert it to a bunch of actually we command a GL polygon, and then we define the points of those paths that we read off of the file. And then all of a sudden we see, for example, A character on the screen. And we the user actually thinks that, okay, we told the OpenGL, and the OpenGL somehow by some magic actually did this stuff and draw that A on the screen, the same A that the designer had designed. But there is nothing as magic in the OpenGL. You have to do all these things manually, and it's very hard to do that. It's very hard to load the path definitions inside the TTF file here, and then grab those points on the path, and then tell the polygon, tell the OpenGL to draw a polygon, and then, for example, fill it with some color. Even though when we actually do these hard stuff, complicated stuff, then we have to write the for example, for writing a paragraph of text, drawing a paragraph of text on the screen, you have to calculate the line width, and then you have to wrap the rest to the next line, and then you have to, for example, you have to do all these things, all these calculations here, and you have to convert them to draw polygons, and you see how much it's complicated, and it is very complicated. But first, before doing that, I see that you are scared, and you should be. And before actually doing this with the TTF files, let's do fun actually drawing text in. That is by drawing shapes. So let's say if we can draw text by drawing lines. For example, what is a character? A character is a line like this, and a line like this, and then a line in the middle. So if, for example, we have, let's say, a function named draw text, which accepts a text. Let's say a text. What is wrong here? Yes, nothing wrong. So let's say inside the text we want to say for each character of this text, because we want to draw the characters one by one. We want to say, for example, when the character is, for example, A, when the character is A, here I want to define how A is going to be drawn by the drawing lines, by commanding lines. Okay, so let's say, for example, for drawing a line. So for drawing a text, we need a baseline. A baseline is where the characters actually rest on. And let's say here we have this val. Let's ask for the baseline. Val, not the val, sorry. Baseline x, and we get it as Flutter point. Let's get it as an integer. And also baseline, the starting of the baseline y. Sorry about that. Integer. And now all we have to do is, for drawing a, let's say we will start a line, and also let's get a font size. Let's get a font size as an integer. We will start from the baseline. We will draw a line, let's say as much as the font size. Then we will, for example, go half of the font size to right. So that will be a draw line, and the points would be 1 point. The first point is on the baseline x and baseline y. The second point will be, let's see, on the same x, but the y will be added, font size. Then now we have a line from the baseline to here, as much as the font size. Then we want to go to the right. For going to right, we have to say x plus, let's say as much as the half of the font size. And the same, of course, the same y as this last point. So it will be like this. Now we have to come, let's say halfway down. So I want to do this, one line here, then I go this way, then come back, and then come down. So if we want to get font size plus, yep, and the x would be, yep. So we cut here, now we are on the same x, but the, yep. Now we are on the same y, but we want to go this way. Then we want to get back to the same line. So again, we added the font size divided by 2. Now we are here. Now we can come all the way down. So the x will be the same, but the y, yeah, I think it will do it. So let's command a draw text to see what will happen. So inside draw content, let's say draw text, and let's give only a, because so far we have just defined the a. And the baseline x, let's say 100 and 100, and also the font size, let's make it 100 pixels. Let's run it to see what will happen. And I think we've got the A, but let's get rid of this draw circle and draw rectangle. And yeah, they've got the A. This is the A. We just did it by drawing simple lines. So if we want, for example, to say A, and we have to, so here inside the draw text, instead of using this X, we have to say var X so far, because we have to move after drawing each character glyph. We have to move and make room to the, and so X so far will start from baseline X, and also we need var space size. Let's make the space size as, for example, font size divided by 10, because we want to have small spaces between the glyphs. So instead of using the baseline X, let's use X so far. Let's say X so far. And after drawing some glyph, we want to move the X so far as much as the so the width, so this space will be space between glyphs. And we also have to define, this should be val, doesn't need to change, sorry. And we need another which is glyph width, and that is, we define it as the font size divided by 2, but we need to replace it here. And okay, now after drawing A, we need to move the X as much as the glyph width, and also space between, making a space for the next character. So if we tell it to draw A and A, hopefully it will draw 2 A's. Yep, we have 2 A's. So you can see that we have this function draw text. We can call it, for example, let's define also space character. What is space character? Space character is just a simple, we won't be drawing anything, but we have to move the X so far when we see a space character. So now if we say I want 2 A's and then a space character and then 2 A's and then a space character and 1 A, let's see what will happen. It seems what is going on. So A character and the space character, and we move it, and it should work. Actually, it should work, but why doesn't I don't know why. Semicolon is redundant there. So we are making room, the space character, just moving the X so far, and we get to the next one. We've used this X so far, and the glyph width, and yep, I don't know why, but it should work, but it doesn't. So it doesn't matter actually. So you get pretty much the idea here. So when you tell the Android to draw a text for you, not all it does a lot, you know. It makes this magic happen. You give your Android framework a text and you ask it to draw at that X and Y, and it just draws that paragraph of text wrapped into lines beautifully. You ask it to justify, it justifies the lines, it distributes the remaining spaces between the words. It does all that. It does all that on your behalf. And how it does is that it tries to convert all those shapes that you see to this simple drawing lines and polygons. And you see those fancy shapes, fancy text, and think that it is doing magic, but it's basic stuff. It's basic stuff, but it's hard to write it on your own. And we are not going to draw text and like drawing a text off of a typeface font file, because it may be thousands lines of code, not hundreds, thousands of lines of code to write a fully fledged drawing text library on top of Opengl. But as we said before, there is this special library here. There is this special library actually, which is named Skija, and I want to show you that. Skija graphics engine, Skija, is a library. So far, we've not used any library, and as we promised, we don't want to use any libraries. We want to first get our hands dirty with very basic and very low level stuff, and then after we see that how things work, then we will come to higher levels, and we will try to use the frameworks that are being maintained by communities and big names out there, because we cannot write our application on our own framework, UI framework built on top of the Opengl. It's very hard. So what is Skija? Skija is a library on top of Opengl, which has got functions for drawing text, drawing image, drawing circle, drawing shapes, drawing paths. It has got all those functions like we did. So for example, like these functions that we've written here, draw text, draw rectangle, draw polygon. It has got all these functions. And for example, when we ask it to draw a text, we can give it a fonts file, a typeface file, and then it will load all the shapes off of that font file, and then it will convert it to draw polygons. So it will talk to the Opengl on our behalf. So far, we've seen how Opengl is working and how it is talking to the GPU. But we want to come actually one step higher, a higher level, and we want to talk to some library like Skija, and then the Skija will ask the Opengl, will convert those commands to the Opengl. So Skija is a special one, actually. I think it's maintained by the Google itself. I don't know. Yes, Google itself. And it's very important, the Skija, because the Skija is the backbone engine of Flutter, Android, Angular, and let me show you all that stuff. So it's for 2D drawing, like we did. So let's see, Google Chrome, Firefox, Android, Mozilla, and all these, and also Flutter, and also there is a special there is a new framework coming named Compose, which is this one, not the Dalvik, sorry, Compose. I'm not seeing it here. The Compose is the JetBrains desktop application framework, and it's on top of the Skija, and also Flutter is on top of Skija. Android is on top of Skija. So the authors of the Android, Flutter, Angular, Compose, and maybe Angular, maybe the React Native. I think the React Native itself is using Skija. All those are not talking directly to the Opengl. All of them are talking through the library, beautiful library of the Google, maintained by the Google, and they just command high-level drawing commands, orders, and the Skija will do this job. But there is one catch here, and that is the Skija is written in C++ and can be used by only the C, C++, C# languages. So in order to use the Skija, we have to write application in C++ or C#. but we want to use the Java and Kotlin, especially Kotlin. And lately, the good news is that actually, if you want to call a function, a native function from Java or Kotlin, for example, a function in a DLL, dynamic load library file, you can do it from the Java and Kotlin, but it's complicated. It's through the native interface. Yeah, I've forgotten the name. And the good news is that the JetBrains itself is doing this for us. They are writing a library on top of the Skia, which simply is the same library. So it's not adding anything to the Skia. It's just written in Kotlin and Java, and we can use it with the Kotlin and Java, and it will call the counterpart function. It will just call that function, the same function in the Skia C++ library, just simple as that. And let me show you that library, Skija library. So they have named this Java library on top of the Skia. They have named it Skija. They have one other named Skiko, I think. These are the open source libraries of the JetBrains, and the Kotlin itself is here. The Kotlin language, you can see it's open source. You can see the code. This is the Skija. The other one is Skiko. Skiko is the Kotlin binding on top of the Skia. So we can use either Skija or Skiko to talk to Skia. I prefer this one, the Skija, because it seems that they are working on this one better, more. And the Skiko is the more recent one, and they are actually they have to do more stuff and make it ready. So in order to use the Skija, so you can see these built with Skija. These are the examples. The Compose framework, which is the framework for desktop applications, written by actually Compose for desktop. And also the Compose we can write Compose with Compose library functions for Android. This uses Skija in actually within. So also other examples, you see all these fancy shapes, fancy UIs, even games. Even you can write games with the Skia, because the Skia will talk to the Opengl. So you have these classes in the Skia. You have bitmap, canvas. These classes have been defined for you. You have paint, path, drawable, image, surface, stream, all these stuff. So as you saw, we, for example, defined point, and if we actually continue that, if we would continue that path, you would see that actually we would define classes like drawables, like circle, like path, like paint, for describing, actually having a higher level here. Let me show you. So this point, this is the class that we defined on top of the Opengl, just to make it more easier to work with the Opengl. And all the Skia is doing is that it has a bunch of classes on top of the Opengl, and that when we describe our content through these classes, the Skia will convert those functions to draw polygons and lines. So how we can use it, they have defined, we have the Gradle. We have to add this to the Gradle file because we wanted to download it for us. So first we want to tell it where to find it, where to download it. URL, it should work, I think. Let's see. I think it should work. And after we told it, okay, where to find it, then we say we want this dependency file. We have to add this dependency to our project to access those classes, the path, paint, canvas, all that stuff. So I add it here, and we have to replace these artifact and version. They have said that, okay, we are working on the Linux. We have to tell it, load the Linux version. Let's get rid of these. These are great stuff. And the most recent version 0.91.2. 0.91.2, I think it is. Let's put it to parentheses, and let's ask the Gradle to load the file. Let's see. Come on. Okay. Okay, let's see if we have set URL. Auto completion, please. Yep. Come on, come on, come on. Yes, it's downloading. You can see that it is downloading the Skija files, and it is adding to our project as dependency. So this is the magic of the Gradle, the build tool. Yes, I think we are ready to work. Let's see how we can use it. So the documentation says, get a start by reading get started. So let's see. Okay, we've added, then we have to import these. Then in order to draw, we need to define a surface. Then we need to ask the canvas of that surface. Then we need to define a paint. And you saw the paint we had. We didn't actually extract it as a class. The paint, all the paint does is that we tell it, this is the brush. So the canvas is the canvas and the paint is the brush. We tell it, we want to draw a line from here to here, but we grab a brush, we tell it we want to have a color of red, so we put it to the red color, and we tell it we want the line width to be 1 pixel, and we define other stuff, and then we draw with this paint. So the paint actually defines a bunch of constants and on how we are going to draw the next shape, the color, the width, all that stuff. So, and we can draw, we can get a picture. Let's get down here. So another thing that it is telling here is that the Skia library is not capable of doing windowing stuff. So what is windowing? So when we run this application, run any application, all the applications are running on top of a window. So this is a window. You can see this buttons here, and inside this, the red section is the canvas, but the canvas has to reside actually on some of a window. We have to ask the operating system for some kind of a window. Then we are able to draw our stuff, define our shapes through the Opengl to some frame, and then we ask, okay, for the next frame, draw the shape on the canvas of this window. So again, for windowing stuff, they have actually, hopefully they have suggested to use the LWJGL, which is the one that we are using right now. So we have done all these stuff. We have these stuff here, and we have our window out there. All we need to do is that after calling create capabilities, we have to create a Skia Opengl context. So I copy and paste this line. These are Java program, but when we copy and paste it, so let's find the, yes, here is the create capabilities. When we paste a Java code in a Kotlin file, it actually asks us to convert it to Kotlin, and you can see it converted to Kotlin. Then we have to create render target. We don't know what is going on, but we have to do all this stuff. Let's just copy and paste it simply. Okay, width, we don't have width, we have window width and window height And also then we have to create the surface. For creating surface, we do this. Okay, seems surface is, let's import it from the Skija. Yes. And the, let's, yeah, okay. And also then we ask for the canvas. Okay, now that we have the canvas, it seems that inside the while loop, after drawing our stuff, after issuing our commands on the canvas, we have to call context.flush. So that's the last bit here. So inside the while loop, instead of drawing this content, we issue this context.flush, but here we draw our content. So let's see. We draw the content on top of the canvas. So if we say context canvas dot, you will see just a, bunch of draw functions. So we have draw lines, draw image for drawing the image, draw a string for doing that magic of drawing a string for us, draw arc, circle, drawable, I don't know, image 9 patch, image rect, oval, patch, picture, point, polygon, region, rect, and all that stuff, triangle fans. And so you can see that the Skia, which is the backbone and the magic behind Android, Flutter, Angular, React, all that stuff, is just doing those magic through these simple drawing functions, drawing stuff. So all those fancy UIs that you are seeing, you are experiencing, are being drawn at each frame through these functions. So let's go ahead and try one of them. For example, for drawing a circle, this is our own draw circle. You saw that we had to calculate all those points of the path to define a polygon, and it was hard. But we can simply ask the canvas to draw a circle, and we have to tell the X and Y, which will be the center, I think. Let's say 100 and 100. Then we have to, these should be flat. Then we have to say the radius. Let's make it 100. And also you can see it is asking for paint. So every draw function on canvas will ask for paint. So what is a paint? Paint is a brush. We talked about it. So let's create a paint here. Val paint equals paint. And let's see what we can do with the paint. We can say, I want the color of the paint to be, for example, alpha, red, green, and blue. So I change the color of the brush that I'm going to use, and I pass this brush to the draw circle, and let's run it to see what will happen. And boom, we have a circle here. We asked for a circle of green color at 100 and 100 with the radius of 100, and it is just doing that for us on our behalf. So you can see that we can either do this by actually issuing these draw polygons ourselves, or we can ask the canvas, the library, that the Skia library on top of the Opengl, and it will do the same for us. And we don't have to maintain this library. It is ready for us. So let's actually try the funny one, which is the draw text. Let's see what will draw string or text this. Let's give the string, let's say hello there. So we give the X and Y, let's say again 100 and 100. And we give the font, we have to give a font, and also the paint. So the paint, we have it, the font. Let's see how we can access a font. So here it is saying for drawing a text, we can ask for typeface. Okay, we can load the TTF file. Let's load a TTF file. I don't have this one. We have to go to see which TTF file I have. Then we have to create a font on top of the TTF. then now we have a font. We can pass it to yeah, okay, this has to be, yeah, we can pass it to drawstring, but I don't have this inter TTF font. Let's see. Okay, we can ask for a default typeface from the system like this. We can use this one if we have a TTF file. I don't have one here. Let's change it with this one. Okay, we are asking the system to load this TTF file with the name menlo. And let's get rid of this draw circle and see what we'll do. And yes, we have this draw string here. Let's make it bigger, 30, the font size, to see the text. You can see the text here. So it is doing all that magic for us. It is loading the shapes, the paths of the glyphs in the menlo TTF file. Then, for example, when we ask it to print, to draw the hello there with green color, it is just magically, based on the font size, it is drawing those shapes, polygons, and it reads well actually. Yeah, and we have a draw. There must be draw image. Yeah, we have a draw image, and we have to give an image. Let's see how we can give image. Yes, we can say make from encoded. So let's load an image and ask it to draw on, for example, 0 and 0. So for loading the image, we have to load a file and ask for to read all bytes of this file. So let's see where we can find image. We have one. We have a bunch of them here in the pictures. Yep, and the wallpapers. Let me use this one. So, and also the path. We have to give the full path of the file. And let's see. And there you have it. So this is the image here. This is the image that we gave, and the canvas, the Skija, which is on top of Skija. The Skija is loading the pixels, the colors of each pixel off of that file, and then is issuing a draw point with that color, and you see magically that image of yours. So this is enough for this session. It was a heavy session. We talked about the OpenGL. We summarized it. We actually wrote our own draw text. We spoke about how drawing text is magically being done, and then we introduced the Skia. So from next session, we will try to work our own graphical user interface of admin shop to see if we can draw and show the menu, the list of products that we have. We will continue from there. Yes. I hope you have fun. You had fun, and I don't want you to actually. We won't be using these stuff. These are actually a huge topic on their own, and you know, you have to spend multiple years to get experience with this stuff, and we don't want to do that. We just these simple drawings by just searching in the one, and then on top create our own GUI to get